Hi all, my name is Vinita Varghese, working as Assistant Professor at Ratan Technical Campus in Computer Science and Engineering Department. So my topic is compiler design. So we will discuss about Unit 1 in compiler design, this introduction of compilers and lexical analysis. So this is a syllabus. So here we'll discuss about compilers and translators, lexical analysis, syntax analysis, intermediate code generations, optimization, code generation, bookkeeping, error handling, how to write compiler writing tools, find automated lexical analysis, the role of lexical analyzer, the design of lexical analyzers, relevant expressions, find automata, conversion from regular expressions to find automata, and minimizing the number of states of a DFA, and the languages of lexical analyzers, how to implement a lexical analyzer. So the first topic, compilers and translators. So we'll discuss why do we need a translator and what is a compiler. So why do we need a translator? So translator is something that translates a language from one form to another. So here in computer programming, all the languages which we have is a high-level languages which will be written by any developer or a programmer. So we have to convert these high-level language into machine-level languages. So for that we use translator. So compiler. What is a compiler? Compiler is a complex piece of software whose job is to convert source code to machine code, that is understandable code by the machines. High-level languages are written by a developer and machine languages can be understood by the processor. The main purposes of a compiler is to change the code written in one language without changing the meaning of that program. So here we have an example. In one of the machines, it is written in the high-level languages, and I have to get the output of this program in my friend's machine. So how we will get? So the source code or the high-level languages, it is compiled and translated to executable binary codes. And through this executable binary codes, I come to the output in my friend's machine. So this is the output which I have been running my friend's machine. So when you execute a programming language in a high-level language, so it executes in two parts. So the first part is the source program and second part is the object program. So the source program is compiled into object program and the object program is assembled using an assembler and we receive into a target program. So the translator is a programming language processor that converts the computer program from one language to another. So the translator has mainly three types. They are compiler, interpreter, and assembler. So what is a compiler? Compiler is a translator that converts source code from high-level language to machine code. Compilers are much faster than interpreters, but error debugging is a little difficult process. So the languages that we use in compilers are C, C++, and Java. Now the functioning. Here we have source code. The source code is compiled and if there is any error message will be produced or else this language will be given into the machine code for further purpose. So the first stage is so source code is taken and then it checks the source code and validates it. And if there is an error, yes, if there is an error, it will show the errors and it will go to the source code. Next, to convert a high-level language into a assembly language or a machine code, we have certain process. So certain process involves some types of analysis from lexical analysis to target code generation. And in this assembling or in this phases, we have a simple table in which we stores all the inputs and which have an error handler which we use for handling all errors which comes in each phase. So the first phase is lexical analysis. So what is lexical analysis? Lexical analysis is the first phase of the compiler, also known as a stamp. So the main job of a lexical analyzer is to convert a high-level language into sequence of tokens. So lexical analysis can be implemented deterministic fine automata. So we will learn in more about fine automata. We have two types of fine automata, deterministic and optimistic one. So as you said, the output of a lexical analysis is given in the form of outputs. and these tokens is given into syntax analyzer. So what are tokens? Tokens is sum of sequence of characters. So each types of tokens we can see. Type tokens which are ID, numbers, real numbers. Punctuation tokens like voids, recurrent, alphabetic tokens we have. Keyword tokens like for, one, and all. Next, identifier tokens. Operator tokens like addition, subtraction, multiplications, and also filter tokens like comma, then stop like that. So these tokens, how it works in lexical. So first one, it in pre-processing. So these are the certain stages how a lexical analyzer works. So first stage is in pre-processing. So in the simple pre-processing, once you give a high-level language or a source code, the white spaces, the commands, the non-essential characters in the source code is separated in the input pre-processing. Next is tokenization. Tokenization is the process of putting these inputs into sequence of tokens. So we have seen in the here what are the different types of tokens. So each source code in the source code is separated as different types of tokens. Third one is token classification. Token classification is the tokens are classified into identifiers, operators, conclusions, and which type of token is classified. So it is classified into that type of token. Next is validation. Once a token is classified, it will be validated and the final stage is the output is generated. Next is the tokens, different types of tokens. So if it is a Y, it is an identifier token. If it is less parenthesis, it is as a same token. Identifier again, if an alphabet, it is an identifier. If it is a operator mix, it comes to arithmetic operator. Next, again, we have B as an alphabet, so it's again if it's a number, it's integer. If it's separated, it's coming semicolon, right parallel. So it can be different different types of tokens. Now, what is syntax analysis? Syntax analysis is the second piece and a phase of a compiler. So in lexical analyzer, the source code is divided into different types of tokens. Now, in syntax analysis uses the parse tree or syntax tree, and these tokens which have been separated will be syntax like it will be separated into operators and operands. So here we have an example and the features of syntax analysis. First is syntax tree, context-free grammar, top-down parsing, and bottom-up parsing. So syntax tree, the syntax analysis, the, the code which is taken back from the lexical analysis is structured using syntax tree. It will be a tree form. Context-free grammar. Context-free grammar is a formal language which we use to describe the structure of programming language, and also it will be in the form of top-down or bottom-up parsing. Next, we have error detection. If an error is found out in syntax analysis, using the error handle, it is detected and corrected. Next, soon after this, in the syntax analysis, the values which will be given into generate code generation. Next, we have an example. So we have a grammar of language. S tends to C, A, D, and A tends to B, C, or A. So the input string which we need is C, A, D. So here S tends to C, A, D, and S tends to A tends to B, C. So using a parse tree method, we are getting into the output. Next, the different types of steps involved in the syntax analysis. They are tokenization, parsing, error handling, and simple table creation. Limitation of the syntax analysis. So it cannot determine if the token is valid or not. Cannot determine whether a token is used before or not. And also, it cannot define whether it is initialized or not. Next, semantic analysis. So the third phase of compiler is semantic analysis. Semantic analysis is the phase of a compiler that ensures that source code is well behaved or well mannered, it is all arranged. So in the semantic analysis, it involves type checking and variable declaration. So what is type checking? So it will define in what type of data type it consists of, and variable declaration is whether the variable is declared before or not, it will be finding out. The fourth step is or fourth stage in the phase of compiler is intermediate code generation. So what is intermediate code generation? In the syntax analysis, we are getting a tree-like structure from the lexical analysis. In the semantic analysis, this tree-like structures, if there is an integer, it is converted into float. In intermediate code generation, we are creating an intermediate code with the semantic. So here we have the phase of a compiler can be defined as two types. They are from lexical to intermediate code defined as a front end, which is machine independent, and after intermediate code generation can be defined as backend, which is machine dependent. So here we have an example. T1 equal to into float of 16, T2 equal to ID3 into T1, T3 equal to IDT plus T2. So all these four we have seen from the semantic analysis cases. So the first stage is code optimization. So what is code optimization? Code optimization is synthesized phase in the program transformation techniques. So optimizing the code or shortening the length of the code. So in have you seen in code intermediate code generation, we have a lengthy code. So if it's a lengthy code, it is very much impossible for running faster and for storage and all. So for this, we use the code optimization in which we can shorten the length of the code, which will help in memory storage and for faster access. So types of code optimization is machine independent optimization and machine dependent optimization. So we have seen earlier that it can be the base of a compiler are defined as two types. They are machine independent and machine dependent. So independent is something that intermediate code which is transformed here does not involve any CPU register. So machine independent is something which doesn't involve any CPU process or CPU registers. So it is machine independent. Whereas the after that, which is the code optimization and target code generation, which is something that is CPU generated. So it is machine dependent. Okay, so this is in earlier in intermediate code, the same code, it is optimized in the code optimization. Okay, so here is an example of before optimization, after optimization. So the same code, C equal to A into B, X equal to E, till D equal to X into B plus 4. The same code is after optimized, it comes as C equal to A into B, X equal to A, then A into B plus 4. So what has happened here? The X is given as the value of X equal to A is already mentioned above. So the same value we are giving it for A. Next, code generation. So now our main target, what is our main target? We have to generate a low level code for mission understandable code. So that we are getting into the target code generation. So in target code generation, we have to have, so code generation is something that we obtain or that we create from the target code generation. So here we have LDF. If you have again, we can LDF, MULF, LDF again. So what is LDF is loading float. So here R is registers and LD is something that we use for loading. So here we are loading the values in the register R2. What we are registering? We are registering R3 to it. Now next is multiplying float registering to same R2, and we are multiplying the registering R2, which is R2 ID3 into 60.0. Third one LDF, so that is again loading F R1 new register R1, and what we are loading, it is ID2. Next adding F, adding float, again we are registering to R1. What all things are registered? R1 and R2. Next, STF is something known as storing float, ID1 and R1 is stored up. So that is the code generation. Next one is three address code. So the address code is something that we generate from the intermediate code generation. Again, we have T1 equal to C into D, T2 equal to B plus T1, A equal to T2. So this thing we are doing in the assembly code, how it will perform. So first one is load R1 into C. So first one we are loading the C. Next one we are loading R2 into D. We are doing registering D into R2 register. Next we are multiplying C into D. So we'll multiply C into D is registered as C, R1 and R2. So we are multiplying R1 and R2. Next we are loading R3, which is R3, that is multiplied value of CMD. Now we are registering B. You can see B over here. Now we are adding R3, that is T1, and R3 we are adding. Now we are storing A comma R3. What is A comma R2? That is T3. T2 is storing. Okay. Now what is bookkeeping? In libraries, you can see the books which are stored, and we are keeping it in a shelf. Like simple table is is type of bookkeeping in which we are storing all the informations. So if you go to library, you can see a book or a place where all the informations are stored in like an index page. Likewise, simple table is also known as a bookkeeping, where it stores all the informations about the analysis phases from the start to the end. So the things which contains in the simple table are variable names, procedures and function names, literal constants, strings, compiler generators, temporaries, and labels in source languages. Okay, now the operations in simple table are allocate. Allocate is an operation which we use to allocate a new empty simple table. Free is something which we use to delete all the entries in the simple table. Lookup is to search for a name. Insert is to insert a name into simple table. Set attribute is to associate an attribute with a given entry. Get attribute is to get an attribute with a given entry. Okay. Now error handling. Error handling is the process of handling the error in each and every phase of the compiler. So function of an error handling can be defined as error handling detection equal to error detection plus error report plus error recovery. So here each and every process consists of error is reported, and we have to find a way to error recovery, and then only we can get into a stage of error handling. Now the different types of errors and compiler construction tools. What is a compiler construction tools? It uses parser generators for compiler construction tools. So context free grammar is given to parser generator, and syntax analysis we take tokens from to syntax analysis and parser trees generator. So scanner generator is something which description based on tokens of languages. So again, scanner generator, it takes a source program to lexical analysis and tokens are produced. So we have two types: index direct translation engines and automatic code generations. So that's it with today's topic. Thank you so much. Hope all of you have understand the topics. Thank you.